Thank you. It's good to be back in Austin. I used to live here for 2 years and absolutely loved it. Now I live in Maryland, which is cool, but not as cool as Austin. I guess my wife now knows now that it's on video. Anyway, okay. So we're going to take a journey today, and you have a choice from the start, the blue pill or the red pill. First, before that, a show of hands. How many of you have a software supply chain? Yeah. How many of you don't have a software supply chain? Hands held high. Don't be embarrassed. It's okay. More people didn't than did, at least by the show of hands. Okay. So the blue pill is the story ends now. You don't have a software supply chain, right? And you don't need to really pay attention. The red pill, though, is the journey of the conversation that we're going to take you on. And for those of you with blue pills out there, I had to throw in a Deming quote because we're talking about DevOps. You read it, so I don't need to say it. So within supply chains, a lot of you that have read anything about DevOps or read the Phoenix Project by Gene Kim that everyone's saying you should read and you should read. I'll join the bandwagon. I've already been on it. I've already read it. Anyway, within manufacturing, there are supply chains. And every manufacturer, whether you are manufacturing packaged goods like ground beef, whether you are making automobiles, drugs, toys, what have you, and you're doing it at high velocity, you have a supply chain within your organization as a manufacturer. You know you have a set of suppliers, and not just any suppliers, you have picked the best suppliers. And those suppliers give you the best quality parts. And you don't have 15 different suppliers for parts, you have the best supplier for the best specific part, and you have their latest stuff. You're not buying their stuff from 10 years ago and using it in manufacturing. And when you use those parts as a manufacturer in your high-speed production lines, you also know what parts went into what products and where those went. So when you put a nut and bolt into a specific product, you know exactly what make, model, vehicle, year, color, blah, 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 that went into. Because when that bolt goes bad, you want to be able to tell the people that have those bolts, or whatever it might be, or those brakes, or those defective ignition switches, or ingredient, you have that, we saw a problem with it, we're going to recall it, it's bad, we'll replace it. This is super effective. In fact, I would guess any of you in here cannot imagine our world operating in a way where they didn't select the better parts and put them into the products and have the traceability. Imagine if you could never recall tainted beef, if you could never recall the car with bad brakes, if you could never recall the drug that are going to cause some major health issue, right? It just doesn't work that way. But then there's software. So I was just talking to Scott. He's like, who's Sonotype? Never heard of you guys. So anyone in software development has heard of us because everyone uses our products or services. They just don't use the Sonotype thing. So part of Sonotype is we run something called the Maven Central Repository. It is the largest open source repository on the planet. We hold 1 million components in there. I will tell you more about the volume as we move through the discussions, but there are 100,000 plus open source organizations that contribute to the central repository. We handled, I won't get ahead of myself on the slides on the volume, but 106,000 software development organizations on the planet pulled components from us last year. So when you live at Sonotype, you get a lot of insight into what developers are doing and what open source projects are doing and contributing and the quality and integrity of those components and the consumption and all that, but only Sonotype knows. And when I got to Sonotype, I said everyone should know. So we I sat down for 3 months earlier this year and produced some research to reveal that. And I'm going to share that with you today. And everyone here will get a copy of my slides. I'll show you how at the very end of the presentation so that you can take these home with you, as well as the research report. So in software, we have a supply chain. Every one of you that is developing software today has a software supply chain. You are all red pillars within the world of, sorry. That is what I'm looking for. Okay, so open source projects are your suppliers. Those suppliers put things into warehouses like the Central Repository, rubygems.org, pypy.org, the NuGet Gallery, BinTray, whatever it might be. There are also warehouses that you use locally, like a Nexus repository to host those components, as well as your own proprietary binaries that you create. Nexus is one of our products. There's 60,000 instances worldwide, so chances are you might be using it. And then manufacturers, your development teams, the finished goods are the applications. So there is a software supply chain, and my report went into how does this software supply chain work and how does it behave. So I'm going to walk you through a little bit about that supply chain. But from an application security perspective, what you need to know is software development has changed dramatically. And processes throughout the organization that support it, like application security, have not. The pace of consumption and the volume of consumption is gigantic. Software development has changed, but our process hasn't changed enough. And for those of you that understand it, Gene Kim, who wrote the Phoenix Project, who was an early reviewer of the research report that he did, said, if you know how to manage your supply chains, you're going to be among the winners. And the losers will be those people that can't visualize it, can't see it, and can't control it. People like Nigel Simpson, who's one of the lead architects at Disney, said, he was an early reviewer, when I heard about this and read it, I couldn't unthink it, right? So, the volume. Just in Maven Central alone, these are just the Java components, but Java is the largest open source population globally. We did 17 billion download requests last year from Maven Central. Okay, there are only 10 million Java developers on the planet. My mother is not one of them. She doesn't download anything from Maven Central. That growth has grown 30-fold over the last 7 years. This year, I'm sure it will, we haven't heard the early numbers, but I'm sure it will be over 20 billion based on the current rate of some things. So with that said, lots of open source being consumed. It's being used by developers. That means it's going into your applications. What % of your applications now are composed of things that you didn't write, but things that you pulled from the internet so you could assemble and develop faster and be more efficient in your organization? What percentage of a typical application is open source? A, B, or C? Yes. Okay, I have a smart audience here. Most audiences, even the Java developers, Java user groups I go to don't get that so quickly. So 90%, 80 to 90% of a typical application is open source components today. 10% is code that you assembled. How many of you are using SaaS solutions? Right? Scan your applications, analyze them. You know what that covers? The 10%. Right? Those SaaS applications don't cover the 90% of what are known vulnerabilities associated with the open source components that you use. But more on that later. In modern supply chains, to operate at extremely high velocity and have the highest quality products going out, right? The only way that these organizations can do this is through automation. How do we identify the highest quality suppliers with the best quality parts and keep and track and trace those across their life cycle. When you're dealing with hundreds of thousands of components, millions of components in some of the largest organizations, when you have manual processes, they will absolutely not be able to keep up. We'll talk about the open source projects. So this slide is continuously outdated, but I did update it last night around midnight, so we're close at least. There are 1.1 million components in Maven Central right now. Those come from 120,000 suppliers, and there are 10 or 11 million developers. This is just in one open source language, if you will. So not counting Ruby and .NET developers and all the components. And they change 3 to 4 times a year. So within, sorry, I'm clicker happy today. So within your organization, you are not using 120,000 open source projects, right? So how many projects are you using? The slide went by, so some of you might have caught a quick glimpse. How many do you think you're using in your organization? 5,000 to 15,000. A's. Quick show of hands. We got a lot of slides to move through. Nobody knows. Okay. 7,600 suppliers on average. When I looked across the organizations and I looked at how many projects on average is the organization using, different projects, 7,600. If you include every version of those projects, 18,000 unique parts from those suppliers. Toyota firm-wide has 500 suppliers. GM has 5,500, right? A software development organization has more than that. The average downloads per organization were 240,000 per development organization last year. You get a sense of volume. Okay. There's going to be an important theme here. Did you have a question? No. Okay. Now, how many of you have heard, Heartblade, Bash, Poodle, whatever, Venom, all of those logoed open source things. So every time one of those articles comes out, we get the, with many eyeballs, all bugs are shallow kind of comment. There are like 8 blogs in the week that those mentioning Linus Torvald in that response to the new logoed vulnerability coming out. So we did an analysis of Maven Central and the 100,000 plus components that are in there. And we said when there is a vulnerability in a component or its dependency, a direct dependency of that project, how often are those vulnerabilities ever fixed, right? So 59% of the time, they are never fixed. Yeah, at the component level, right? This means you're releasing, if you're an open source project, 3 or 4 versions a year. And even if you have 50 more versions past when the vulnerability was known and discovered, you haven't corrected the vulnerability in any of those future releases. When the CVSS score was above 10 and it was corrected, the average time to correct it for the project was 224 days. That means before you get it in your application development teams. Now add on the time that it takes you to take the good component and remediate it for a level 10, right? For banks, I read somewhere, I think it was 6 months ago, it's like 190 days is a good average, right? So 190 plus 224 is a long time. The best projects did this in under a week. Right? The best projects said, I have a vulnerability in my project, I will release a new version fast. When you think about the suppliers that you're working with, you want to work with these and not these, and certainly not these. So the warehouses. Okay, modulecounts.com. To give you a sense that there are lots of components in the Java world, Pick any development language and you'll see there are hundreds of thousands of different modules across the different languages. And if you're interested in whatever language you're developing in to see how many components are out there, modulecounts.com. It's cleaner when you get the slides, and I'll give you the slides at the end. So the download volumes from Maven Central, or central.sonatype.org, NPM, NuGet Gallery, and Bintray, these are like the newbies, right? NuGet Gallery's been out for like 2 years that they're really pushing it. They're doing 250 million downloads a year, right? Again, think about the number of .NET developers and then compare that to the number of downloads. The volume is really big. And the problem that we have is the communication from the projects, right, and the components to the developers is broken. When Heartbleed hits national news, right, people hear about it. There are 50 new vulnerabilities every day, right? But the developers that use the components don't hear about what it is. They just use the component because it makes them faster and they get their products out the door faster and it makes them more efficient. And we are gigantic advocates of open source and using that, but you have to pick the best quality parts from the best quality suppliers when you operate. To give you also a sense of how things work, when I did this research, you have build tools. You might have some of these within your organization. Those are things that automatically call Maven Central and say, I need a component. I want to download it. We need it for this particular build, right? There's a more efficient path where the development teams go here to a local repository like one of these and say, I need to download a component instead of going to the central repo. Now they do this because this is 10 to 20 times faster than this, just by distance, right? Right. You're using a proxy. It's a lot faster. It's sitting right next to your tools, what have you. So I don't want to name names of organizations. Just throw out numbers of how many developers your organization has. Just 100, 500, 300, 450, 8, right? Okay. Whatever your number was, that is how many people you have in software procurement, right? We don't take the number of designers and people on the manufacturing floor at Ford and say that's how many people are in procurement, right? They have a procurement department that says, we know what we're sourcing, we vetted these components and we're bringing them in. In software development, it's much different. If you have 2,000 people in development, you have 2,000 people in software procurement that you've outsourced to. When you use a local repository, and these are open source things that make developers faster, they can also make you more secure, right? Because you can't audit or trace this or even get a grasp of it unless you're the guy with 8 developers. Then it's easy. But if you have hundreds and you're pulling 240,000 components across those developers, you can't trace what they're doing. If everyone goes to a local source here and only downloads the new things, you know exactly what they have access to, right? It's super simple, and it makes developers' lives easier, and as security professionals, it is a huge step to being able to understand what you're consuming, and it doesn't cost you anything. And I don't care which product you use up there, even though one of them was ours, but there are ways to get your organization to use that, and developers will love you for it. So what percent of downloads do you think were pattern 1 versus pattern 2 in the research that I saw? How many people do you think are going the longest path? 90? No? B? 55%? Anyone for A? Who would take the longest route, right? I always say, like, I love strawberries, right? And I love going to the field to pick my strawberries once a year with the kids. And they love it too. I pick them, they eat them, right? And that's totally awesome, but I don't go to the field every week or every day that I'd like to eat strawberries. But 95% of the time that developers want their stuff, right, they go to the fields to get it, right? And as a security organization, trying to protect this behavior and trying to understand what are you bringing into your organization becomes extremely difficult with that kind of behavior. So anybody can get it. What you have to So what you have to do is you have to have policies in place, and you have to say, look, Maven or any other build tool can go out and just point directly to the internet and get those components, and that's kind of the default setting of it. Yes. Yeah. But if you proxy it and pull them down, you pull once, and you can use it as many times as. Yeah, but you don't use we have 1.1 million components, you don't use that many. In fact, you use, on average, 6,700, right? But you pull those 240,000 times. So if you knew what the 6,700 were, you'd never pull anything. You'd pull 1%. So we've seen organizations like JPMC, for instance, they went from pulling 3 million components a year to pulling 95,000 a year because they told their developers, everyone has to point to the proxy, to the repository manager, because we have a flood of stuff coming in that is unvetted from unknown sources, from unknown origin, and that is a huge security risk in our organization. Very little. In fact, so the CISO, this is a public story because I was in New York when he was telling it, but the CISO, when we said, who's the largest consumer of open source components from Maven Central at the time, right? And this was many years ago, right? He's like, easy, IBM, no. Microsoft, no. Federal government, no. JPMC, the CISO, it's you. 3 million components a year. And you know what he told us his staff size was to look at that? That's the answer. Yes, 0. He had no one using it. Oh, DevOps. So DevOps, high velocity. We want to go faster and faster. We're not going to do 2 releases a year. We're going to do 20 releases a year, a day, a minute. Right? I was just at the DevOps Enterprise Summit. The stat that Amazon is doing like 5 million releases a day now or something. It's like insane, right? So to keep up with that, you have an open source policy in place at your organization. How many of you were here last year when I was presenting the survey results from the open source and application security survey? Oleg was on my panel there talking about this, so he knows the answer. How many organizations don't have a policy in place for governing open source? Like, you're not allowed to use bad components or components with bad licenses.
E99.
You're close. Okay. So 43% of organizations said, no, we don't have a policy in place to manage open source. I surveyed 3,500 development organizations last year. Okay, that was the next question. Kind of. Okay, so out of those, you have 57% have an open source policy. We're going to try and protect what our developers are using. We've told them, don't use bad stuff. We have it on paper. That paper sits right next to their laptop, and they look at it every time they run a build. So do you actually follow your company's policy? 68% that had a policy said that they followed it. And we also ask, have you ever been breached due to an open source component related breach in the last 12 months? Now, this was a public survey, and I'm totally surprised that 1 out of 10 people said yes. Like, I know who they are. And they told me, yes, we were breached. Like, that list went away of who those names were. We didn't want to reveal the guilty. But in the DevOps practices, when security comes in and says, hey, by the way, we're going to do an analysis of your application that's going to take 8 hours, or we'll be back to you with this scan and the results in like 2 weeks, and we'll tell you what's bad, or we're doing this at the very end of the development life cycle before release, and you've already done 40 builds in order to get there, and we're going to check at the last step, and then we're going to find bad things, and then we're going to ask you to rework those, and that's unplanned, unscheduled work, and now I hate you, and you're the guy with the shovel at the back of the unicorn. So in the DevOps world, if it doesn't fit, it doesn't get done. And they don't, it's not that DevOps folks don't want to work with security, and security wants to figure out how to work with DevOps, but you need to totally change the way of thinking in terms of, I need something that actually works at the same velocity that my developers are working within these organizations. So I did look at the download volumes, and I found, as we said before, 240,000 that were downloaded. 15,000 of those. 1 out of every 16 of these had a known critical or severe vulnerability. For every single solitary download last year, 1 in 16 includes a known critical or severe security vulnerability. We run the repo. It's open source. We can't tell you what you shouldn't download, but you're not vetting it. Your developers are not vetting what is coming from these, and it is infecting your applications. And I get this report. When I do this analysis of these organizations. I get million-line spreadsheets if you downloaded a million things, and it says, here's the date, here's how many times you downloaded it, here's the group and artifact and version of that, and here's what pulled it, like Nexus or Puppet or Jenkins or something like that, and does it have a known CVSS score or vulnerability, and what's the license type on it. And everyone knows the CVSS pattern or protocol, right? It's CVSS-year-4 numbers or so, right? So I'm looking at these million-line spreadsheets and sorting through them, and the CVE-2003- is like pages. And then after that, it's 2005s and pages, and 2006 and pages. And I'm like, ah! So what scared? 3 things scared me about that, right? 1 is the volume. 2 is you're a developer and you are using a component that was known vulnerable since 2003. The 3rd thing is you're using a part that was developed in at least 2003. It's 12 years old. Dude, there are like 83 newer, better, less buggy, more functional versions of that component out there, and you're still using the same component that you used in like your high school, final project because it works. So 66% had known vulnerabilities that were 2013 and older. If there were loads of 2015s, that's excusable. They're newer, we haven't had a chance to adjust. When they're getting older and really old, then my clicker is like super happy. Then things are bad. So then I also looked at this pattern of, there was a story, quick story. There was a bank somewhere that was using Spring Core. And the joke inside Sonotype was they had downloaded the 51 of 58 versions of Spring Core in the last year. So they were 7 away from perfect in their development organization, that they were using almost every known version available. So I looked at the top 100 downloads of what people were consuming within their organizations. And within those top downloads, there were 27 versions on average of every one of their top 100 components that were downloaded, right? So whereas Ford has 1 muffler for 1 vehicle, one version of something that they use, right, across 100 different types of vehicles, or maybe the analogy is getting too wide there, but you could manage 100 different parts, or you could manage 2,700 different parts. As an application security professional, which is easier to manage, right? Which is easier to maintain? Which is easier to service? Which is going to create less of a vulnerable or exploitable landscape for you? So Land Rover doesn't use like 27 different mufflers in their vehicles in a single year for a specific reason. It's easier to manage. And if things go flawed, then they go, let me get a new clicker. It's defective. Clearly, they're bad parts or it's a bad finger. So Google manages 2 versions of their components within their organizations. They have a mandate across their organization that says you're allowed to use open source, but you can only use one version. And if you need an excuse, you can use 2. Right? There is a mandate across their organization on what they can use so that they can control their software supply chain. And if something goes wrong and someone says, there's a new vulnerability in that component, did we use it? How quickly do you think they can answer that? Super quick. We only use 2, right? And here are those 2. We have an exact trace of what we used across all of our thousands of developers, right? Another organization, Topo, who's one of the guys presented at DevOps Enterprise Summit, it's on Tuesday of this week that I was there, said in his repository manager at Capital One, right, they have one version of every component that they need for development. They do not allow multiple components in because it streamlines their development process, their security process, their legal reviews, their quality reviews, that they are using the best quality part, the latest part from the best quality projects to make sure that they keep their environment clean. So we'll look at finished goods. We know that there's bad stuff out there that doesn't get fixed, that's in a warehouse, right, a central repository, and we know some of that is downloaded to local repositories that is then consumed by developers, or they're just pulling it directly. So we have a free service called Application Health Check. It's similar, but I'll say better than OWASP dependency check, but use both. They're both free. It doesn't matter. Within those, the couple thousand applications that we've analyzed, right, we found there's an average of 106 components. There are 106 circles up there. Right, 106 components, and the average is that 23% or 24 of the 106 have known vulnerabilities, critical or severe vulnerabilities. Almost a quarter of the components of what are in your apps, right, are vulnerable. And the weird thing is, and honestly, we haven't figured out exactly why yet, but only 1 in 16 of what you're downloading is known vulnerable. But by the time it gets into applications, applications have nearly a quarter of their components vulnerable. And we need to do a little more research as to why the number kind of explodes at the end of the release cycle. We have a couple of theories, but I'm going to try in next year's report to see if we can get a little more data on it. So your software supply chain is very efficient in flowing things through. So software supply chains, with software supply chains, we can learn a lot from what the manufacturing industry has done to have better quality products and safer products and produce them at high velocity and keep that quality and integrity high. And I think this isn't the particular article about Jeeps being recalled for software recalls, but I think all of you heard or read the Wired article back in August on the Jeep that was stopped on the highway with the truck coming up behind, and that was, I'm glad I wasn't the guy that was driving from Wired, in that scenario. But you also remember that within a week, Chrysler said, we are recalling 3 million Jeeps or whatever it was that have this software component in them. And do you know why they can tell where their software is, and yet the vast majority of us have no policies in place to track and trace what goes out where? In my survey, there were 23% of all the organizations that answered that said we're totally locked down and we have full visibility. So 75% of organizations don't. It's because the auto manufacturers have a managed supply chain. They know every piece of software in every vehicle and every make, model, year. So when they have a problem and there is a defect, they can make a recall. So their mean time to detection is 0, right? They know exactly where it is. Their mean time to remediation is longer because you have to bring it into the dealer to fix it, unless the cars with Wi-Fi are going to allow you to do it over the air, but that's a whole other security issue. I don't know. And usually it's not revealed, because if it was open source and they revealed it, then that makes the exploit path really easy to figure out. And then you just figure out who else used that, what other automakers use that same part, and you can shut down 3 million cars across the country or the world at once. And that, I won't get into any details on that, if that was even possible. But anyway, so there are ways that you can find it. The old process is the National Vulnerability Database. Look and research that, see what's new, keep a spreadsheet. Here's your blacklist. These are bad things to use. Don't use those. And on occasion, I'm going to look at your applications and find out what's in them, right? That is the old process that cannot work at 240,000 components being consumed a year. If you look at things like introducing a WASP dependency check, our application security check from Sonotype, Fortify and Veracode in their portfolios have open source and third-party vulnerability checks in their software. We're at a gigantic insurance firm that you've all heard about a couple of weeks ago talking to them. They said, we have one of our major applications. It has 44,000 files in it that we needed to analyze, and that takes us weeks upon weeks to do that. The open source analysis and third-party analysis for them, this happened to be with our product, but these other products are not going to be different. In fact, HP's analysis is Sonotype's. This took them 2 minutes to scan that file. This stuff is quick, and it gets you the information about what is the known vulnerability and the known parts that are in there. So if you're not using these in your organization, here's a quick way. The first two, at least, are free ways to just look at your applications and see what's in them. So you have an opportunity to be this person, or you have an opportunity to be a dynamic duo with the development organizations. And there are some easier ways to go about doing that. The first way is this new way of thinking, and this higher velocity is you can help developers. This is a very quick, it's not a product pitch, it's just to tell you there's technology out there that can help solve a problem today. In our solution, we will tell a developer in their IDE, here's the component that you picked. This has license issues here, no license issues here. This top row is, these are the popularity of the components that are being used. This is the most popular one. It's got the least amount of security vulnerabilities associated with it, and it might meet your company policy. If you tell a developer as early as possible in the development lifecycle, here is a better part to choose from. You pick the part. You want to use this. There are lots of versions of it. Here's the safer part. The mean time to detect is 0, right, for that vulnerability. The rest of the development lifecycle goes a lot smoother. The amount of rework is less. Your vulnerability checks, even if they're at the end of the process, will get better because there's less chance for that component to go bad over time. Sorry. I'm going to get a new thumb. If you're doing Jenkins builds or Bamboo or Hudson or whatever, there are integration to those platforms that say the build was stable, not stable, what have you, but every single build can tell you how many components were in it, Were there any security risk or vulnerabilities within those components? And you can set policies to say alert someone, inform someone, show the developer the better choice that they can make, or even, if you want to, enforce and break the builds within those organizations. Creating a software bill of materials, the OWASP dependency check, right? The Sonatype application health check and the other tools can create a list of the components that you've used in your applications. So the applications that are out in production before they're released, if you do one of these analysis and you have the list of components and someone says, oh my gosh, the Tomcat version component 2.8.16.4, did we ever use that? Right? Yes, we at least kept a list of what went out the door before we shipped it. And there are links at the bottom of these pages to show you where to get these kind of free services. Tomorrow, our CTO, Josh Corman, is talking about the impact of these kind of behaviors and others on the Internet of Things at 10 a.m. Hold on. So, this is my email address, weeks@sonatype.com. If you email me right now, you do not need a subject line, you do not need a thank you, you do not need anything. Weeks@sonatype.com, you will get the report, you will get these slides, you will get the survey from last year, and you will not be opted into any marketing flood of emails that come. There is a link at the bottom that says if you do want to opt in, here is the link for that as well, but I will not spam you or anything. And I have enough people in this room that I have a competition with my friend Mark, who also works with me on this activity to get people's slides at the end, which is cool. I stole it from Gene Kim because I think this is a cool idea because everyone always wants the slides. And next week when you think, I need those, where do I get them? I don't want to wait for LASCON to upload them. Blah, blah, blah. You have them, but Mark had 30 people request all at once, but he had a room like 500, so if I can get all of you, then I can go back to Mark, and I have this on video, but that I got 90+% of the room to say they want the slides. So Josh Corman and another security researcher, Dan Geer, who you guys all might know, the link for that article, it's called Almost Too Big to Fail, if you just Google search that, but the link is in the slides as well. That article provides it's a 4 or 5 page analysis where they walk through what did we look at, how did we look at it, and the method behind it. But yeah, it was, we at Sonatype, we knew that. Like, we've known that for a long time, but there's a lot of dogma out there that says, look, there are lots of people working on this. But then like things came up last year, like Heartbleed, and they're like, oh, there's only like 2 people kind of working on that project. Well, and they're not, for the most of projects out there where you might have hundreds of developers or contributors on those, how many are security professionals? How many are actually trained to look for stuff that might be known flaws? And then how many security? Think about, in Java alone, there's 1 million projects or 115,000 projects. How many application security professionals are there in the world? Right? Yeah. Yes, we would love, no. And we're trying to figure out a way to inform those projects like, hey, your stuff has been known bad for years, and there are alternatives out there to some of those dependencies you might rely upon. So Ford Motor Company does not make their brakes. They get them from Delco, right? I don't know anything about auto manufacturers, even though I have cars in my slides. So let's say they get them from Delco, right? And the brakes are bad, right? Do we sue Delco? No, right? We sue who? I bought the car from Ford, I go after them, right? So the liability is, you have as application security, the good thing is, with components and packages that are being used, they're identifiable, trackable, traceable, they're the same everywhere they're used. They're easy to find. Custom code isn't, It was incredibly difficult to find these things in the past. Now that they're all the same, we know everyone that used that version of that component is the same everywhere, and if it's vulnerable one place in that circumstance, it's vulnerable everywhere in that same circumstance.
And I think in your example, Ford would go after Delco, right?
Yes.
Might be a little different in our software.
Yes. But you have to realize, like, think about
They actually paid the Delco somehow.
Right.
Think about any industry, pick any product that you love, right, that you use. 23% of the manufactured parts in there are defective or known vulnerable or putting you at risk, right? I said at the beginning, application development has changed and security processes haven't changed enough. We need a way, the velocity, the consumption is not going to slow down. We've had organizations that when we told them their consumption, they said, we've got an easy solution. We're just going to stop using open source components. So the developers all say, great, we're quitting. How are you going to stay in business? Because that's not going to happen. The volume is not going to get any less. So what I can tell you, whoever you are, big or small, whatever country you live in, whatever application you're developing on, 1 in 16 of your components that you download is known vulnerable. If you download 100, right, then you have 23, 22 vulnerable components in your environment. It doesn't matter across the board. And there is no one that we saw out there, and I will say no one, out of 100,000, if there are 4 organizations that are really good at this now, then I would tell you the vast majority are around the average. We see organizations where 17% of what they're pulling down compared to the 6.22% average, 17% of the things they're pulling down are known vulnerable. So there are slightly worse, but no one's like super bad, but no one's immune from the issues at hand.
That's a really good suggestion.
But I'm around at the Sonotype booth. If you guys have more questions, happy to answer. And thank you very much. I appreciate it.
Okay, thank you. Thank you, Derek.
Thank you.